Okay, these are some notes for section 4.5, and two of the topics we're going to cover in this section. One will be linearizations, and the other will be Newton's method. So we'll talk about linearization first, and you just have 1 through 6 to do in your homework, and they're all the same thing. You're to find linearizations, L of x, of f of x at x equals a, etc. And then if you read that carefully, in that case, a will be, they say a is going to be different numbers, and then you're going to try to find it at a plus 0.1. So number 1, it's 2, so you're going to find the linearization at 2.1. And at number 2, it's negative 4, so you're going to find the linearization actually at 3.9. That's negative 4 plus 0.1. So hopefully that is, it makes sense to you. But anyway, what is a linearization? What is that? That's actually just a tangent line. And all we're going to do is, if we have a function here, and sometimes it's maybe complicated to find the actual value of a function at this point. It could be a more complicated function. Could be a cubic, it could be have some fraction in it. And if I wanted to evaluate my function at this point, let's say b, then I'd have to put the value b into the function. It might be hard to work out. So if we use a linearization, a tangent line approximation, sometimes they're so close it's a lot easier to do as far as calculations are concerned. So keep that in mind. So let's say we pick a point center a that's kind of close to where we want to find the root. Okay, so we'll pick this point, and they'll actually give you this a in the homework problems. Like I said, number 1, a is 2. Okay, and we want to approximate, like I think it's 2.1, and they give you a function. So let's say this is my center here. Well, if I find the equation of the tangent line to this curve at that point, then that's going to be this little blue line. That's the tangent line. Now I can do that. I know how to do that because if I've got a point and I got the function, I can find the equation of the tangent line. And then if I want to evaluate b at this tangent line, and remember a tangent line is a line, and it's a lot easier to put values into a line than maybe into a complicated function. Believe it or not, that it makes a lot of sense when you think about it. So I'm going to get a line. It's a lot easier to, like I said, put one value into a line and get the other value. It's very easy. So if I look at this point B, and if I draw this tangent line, and if B is close enough to A, if I look at the linearization, if I look at the L of B, that's going to be right over here, where this is actually F of B. Well, look at how close they are. In other words, if I kind of go over here and look at the vertical position, which is actually the value, that's what I'm looking for. This is L of B, and this is F of B. They're pretty close together. And as B gets closer and closer to A, that tangent line approaches, the value of the curve approaches, the value at the tangent line. So for B relatively close to A, I'll get a pretty good approximation, and it will be probably a lot easier to find that out. As a matter of fact, a lot of these problems you could do with calculators that you normally couldn't. So that's what this is all about. So we're just going to find the equation of a tangent line. That's all. And then we'll just evaluate we'll evaluate the value at the B on the tangent line, and we'll hope that we're close enough to the actual value of the function to have a good approximation, something that will work. Okay, so that's it. Tangent line is what we're going to get, and we're going to evaluate that. So I hope that sketch makes sense. Okay, so let's take a look at a couple of examples. Okay, the first one here, this is f of x is going to be the square root of 1 plus x, and we're going to use a centered 0, and we want to use this to approximate. Okay, use L of x to approximate the square root of 1.01. I'm sorry, 1.02. Okay, so if I graph my function here, this is good old John Travolta. Remember, it's just shifted 1 to the left. It would be x plus 1, so I'm shifted 1 to the left. So it looks like this. And if I'm going to use my center point or my point of tangency to be x equals 0, you can see the blue line is the tangent line. And then we're going to approximate 1 plus x. That would be 0.02. You'll see me right over here. We're going to be pretty close. Okay, we're going to try to take the square root of 1.02. Well, if 1's already in the function, then 1 plus, if I want to find the square root of 1.02, I'm just going to use 1 plus 0.02. So that's what x is going to be, 0.02. And we'll put that into the actual function. So you'll see that in just a second. So first of all, let's find our tangent line at 0. Okay. All right, so because that's going to give me 1 because I have a 1 in my function. Okay. So let's take a look at that. So how do we find the tangent line at x equals 0? Well, at x equals 0, first of all, my point of tangency will be 0. F of 0, if I put 0 in here, f of 0 is the square root of 1, which is just 1. So that's my point of tangency, 0, 1. And then if I want to find the derivative of this, that's easy. That's just going to be 1 over 2 times the square root of 1 plus x. And then if I put 0 in there because I want to take the slope at 0, then I just put 0 in there. The square root of 1 is 1, so I have 1/2. So that's my slope. So again, if I use my tangent line, or it's just going to be y minus y1. This is y1, so y minus 1 equals m. In this case, the slope, m for the tangent line is 1/2 times x minus x of 1, which in this case is 0. So I just end up, if I add 1 to both sides, y equals 1/2 x plus 1. So this is just the tangent line. All this is the equation of the tangent line. The equation of the tangent line, okay, to my curve, y equals the square root of 1 plus x at 0. That's all. Okay. Well, since there's a 1 in there, if I want to evaluate this, if I want to find the linearization of this, well, I'm sorry, let me get back here. This is the tangent line, right? So all we do is call that the linearization. That's the same thing. It's exactly the same thing. So the linearization is just a tangent line. Linearization means straight line. So it's a straight line approximation around that point. So I just call this tangent line, instead of writing y, I just write L of x. And that's my L of x. Now if x is 0.02, because I want to use this for 1.02 and I already have a 1 in here, so I'll call x 0.02. I'll just find out what that value would be. So if I put 0.02 in here, and you see the 1 is going to take into consideration that one that was involved, okay? Then if I take a look at this, if I put 1/2, if I put 0.02 in here, see how easy this is to evaluate. 1/2 times 0.02, that's just 0.01, plus 1 is 1.01. And there's my approximation. So the square root of 1.02 is approximately 1.01. Now that might seem trite, but that gives you a pretty good approximation because I'm pretty close. Okay, 0.01 is pretty close. Okay, actually 0.02 I should say, yeah, it would be pretty close to 0. Okay. Now, they also ask you to find the error, so this is a simple little technique. All we do is we look this up in the calculator. Now, there are mechanical ways to take the square roots of numbers without using a calculator, but they're very difficult. You know, you think long division is difficult, that's real difficult. So we don't teach that anymore, but when I was a boy, we had to learn how to do that. And it was kind of a pain. Anyway, it'd be nice to go back there and check it out sometimes just for fun. But anyway, what they want you to do is check the error. This is how you check the error. You just take the square root of that, put that in your calculator. Well, if you put the square root of 1.02 in your calculator, you get actually 1.009950.494. All right, we want to take the error, so we're going to take the difference between that, my f of x, and my L of x. That's going to give me the error. So I take the difference of what I got versus what my calculator would give me. And if I work that out, I end up with, if you put this in your calculator and take the absolute value, you end up with 4.95 times 10 to the minus 5. Now what does that tell us about the error? Well, this is a little error technique. We would write 4.95 all over, and then 10 to the minus 5, that's 1 over 10 with 5 zeros. I'm sorry, 1 over 1 with 5 zeros, pardon me, 1 over 1 with 5 zeros, so I have 1, 2, 3, 4, 5 zeros. So this is the same as that. Now when we're doing these error approximations, this is the way you handle it. 4.95 is less than 10. We try to find a power of 10, and that's just 10 to the first. So is this true? Yes. But I can reduce this because I've got 10s in the top and the bottom, so I can cancel this out. So this is 1 over, instead of 5 zeros, I now have 4 zeros, which is 10 to the negative 4. So we say the error is less than 10 to the negative 4. Get this up a little bit higher. So that's how you deal with the error. Okay? Again, when you figure this out, you get this, and then you try to find a power of 10 that this is less than. If this was 49, it would be less than 100, but in this case it's 4.95, which is less than 10. So I've got, this is definitely less than this equals this equals this, and that's my error. So we'd say the error is less than, because I got a less than here, less than 10 to the negative 4. And that's all you have to do. And we'll give you another example in just a moment.